All right, so this should be relatively short. Hopefully, I can keep it to like 10 minutes. So, we can do reactions with all these different types of functional groups that we learned: hydrocarbons, alcohols, all that jazz. So there's a lot of different reactions, but because of the pace of this course, I'm only going to cover the ones that appear on the exam. So the only ones that appear on the exam are reactions with alkenes. So if we remember, alkenes are when there's a double bond present. So I just want to talk about in general, how reactions with alkenes work. Okay. So in general, we have the squiggly line represents the rest of the structure, whatever it may be. Somewhere in our structure, we have a double bond. So that's what I am depicting here. So anytime certain reagents, and we're just going to call them A, B, I'm going to give specific examples here in the next few slides, comes into contact with this double bond, it breaks apart the double bond and aligns whatever is AB happens to be. And again, it'll make more sense when we see specific structures. It's going to align or put itself onto the structure. So it's going to break apart and put A on one carbon, B on the other carbon. Again, remember there's these implied hydrogens. All right, so that's generally what's happening on. Something comes in contact, it breaks apart that double bond and puts itself on the structure. Okay. All right, so in general, reactions, we can have reactions with HCl, HBr, HF, etc. These are strong acids, right? So this is the AB. So here, again, we're going to draw this kind of general structure. We have an alkene bond, but now we're going to add HCl, or again, this can be HF or HBr, right? Doesn't matter. And then we're going to break that double bond and a hydrogen atom, and then whatever else is present. So in this case, chlorine is going to put itself onto the structure. Again, implied hydrogens. All right, so if we got more specific here, so this was just in general, got more specific. Here we have 2-butene. All right, so ene because the double bond is present, but because it's a 4-carbon parent chain, 2 because the alkene bond spans from 2 to 3. So if I was to add HCl to 2-butene, it's going to break that double bond and add a hydrogen and a chlorine to the structure. And because most of our hydrogens, if not all of our hydrogens, are implied, then it doesn't matter it doesn't matter if I put on that hydrogen or not. So we also could have put it on the chlorine on the other atom, but if you notice when we go to number, we're going to end up naming it the same, because I'm going to want to number this guy on the left from right to left to put this chlorine atom at the lowest naming conventions, because we just created an alkane. I should have started by saying that. But by breaking this double bond, we've just created an alkane. So now I'm using alkane naming conventions. If the structure on the right were to happen, I start naming it, I'd want to name from right to left. And if you see here, it's going to end up being the same name. All right. So alkane naming rules. This is an alkane now. So it's ending in ane. It is still 4 carbon though. So it's still butane. But now we have, instead of a double bond, we put this chlorine atom on there. So 2-chloro. We got to tell the audience it exists. So 2-chlorobutane. All right, so we have this guy to remember for our exam. And we have one other reaction that can happen. And that is with where AB is water. Okay? So in general, we have this generic double bond structure. If our AB was to be water here, this is what was going to happen. So we're going to go from an alkene to an alkane. And no, actually I lied. We're going to become an alcohol this time, and I'll show you here. All right. So the same thing happens where we break this double bond, and we're going to add 2 components, our A and B, onto the 2 sides of the double bond. For H2O, a hydrogen gets added on and an OH group gets added on to the other carbon. So in general here, an H group would be added and an OH group would be added. And so we now are going to name our product of this reaction some type of alcohol. All right. So we talked about the general reaction with water and alkenes. And so now we're going to work on a specific example. And so here I've drawn 1, 2, 3, 4, 5, 6 hexene again, but now 2-hexene. So I move that double bond. You'll see why here in a minute. So if I have an alkene and I add water to it, that double bond is going to break. And I'm going to add H and OH across it. So with the example I did before, it didn't matter which carbon I put the groups on, and that only occurs with a terminal alkene bond. So when the alkene bond is at the end here or here. But anytime the alkene bond is in the middle, we employ this rule called, and I'm going to probably spell it wrong and say it wrong, it's Markovnikov's rule. And so it's kind of simplified by the same saying, the rich get richer and the poor get poorer. So with these reactions with alkenes, right, we always have one group that's just a hydrogen and the other group whatever else. So with water, it's OH. With the last slide we were working on, it was, Cl, Br, I, fluorine, whatever. So this group, the one that's not the hydrogen, is the more rich group, where hydrogen is the poor group. And we want to add the rich group to the more substituted carbon. So if we're choosing between this carbon and this carbon, we want to add it to the more substituted one. Again, I thought I started this thinking I drew the right example. Okay, let's pretend that there's a line here. All right. So the more once I added the methyl group, the more substituted carbon is this guy. He has more other carbons coming off of it.
where this one has less carbons coming off of it than this one. So if there's a choice, we want to put the rich group on the already rich group. The rich get richer and the poor get poorer. All right. And so that ends up giving us, so we went from an alkene to now an alcohol. We can name this for practice here. Let me erase some of this stuff. Make it a little bit more clean. All right, so if we number our carbons, 1, 2, 3, 4, 5, 6. So because now it's an alcohol, it's going to have the ending -anol. We have to tell our audience, hey, this is coming off of carbon 3. The OH group is coming off of carbon 3. We also have to tell our audience about this branch here. And so also coming off of carbon 3 is a methyl group. So 3-methyl-3-hexanol. All right, so that concludes this lecture. And of course, I have a list of topics on the final, specifically from this lecture. And I just realized I forgot to put slide numbers by them, but hopefully you'll be able to go back and figure out the slide numbers and stuff.